me, I'm a nightmare in action. Bop, bop.
As we have seen in the past, having a lower center of mass generally keeps you more stable. For example, if you have a water bottle that is empty and a water bottle that is half full, which one would fall over first? The water bottle that is empty would fall over first because it has a higher center of mass than the half-full bottle. So, the same should apply to using a slackline, right? No. As it turns out, having a higher center of mass actually benefits you here. This is because of an object's rotational inertia. You can compare this to trying to balance an object on your finger. Trying to balance the same bottles on your finger gets you opposite results as the previous demonstration. Having a larger radius in an object gives you more rotational inertia from the formula inertia equals mass times radius squared, and the more rotational inertia an object has, the more torque is required to rotate it, or the harder it is to rotate. So, by getting as tall as you can and putting your arms above your head gives you a larger radius than just standing or squatting. By giving yourself more rotational inertia, you are also giving yourself more time to correct yourself if you start to wobble or fall off, making yourself more successful when you try the slackline. Since the formula for rotational inertia isn't just radius, that means there are other factors too, such as mass. So that means if you hold an object when you're walking the slackline, you will have even more rotational inertia. So, I grabbed the heaviest object I could find, my algebra textbook. So, in conclusion, we talked about how on a flat surface, such as a floor, you need a lower center of gravity to balance. We also talked about how having a higher center of gravity is better when you are on the axis, such as a slackline, because it gives you a larger radius and larger rotational inertia, which requires more torque to make you unbalanced. Also, having more mass gives you more rotational inertia.